Good morning, this is Mr. Elmhorst. The math lesson, we're going to take a look at this ratio within circles where we can calculate something called pi, and we're going to use this in circles, circumference, and then also when you get into area. So have you heard of the Greek symbol pi? So a little wavy line. Or do you know what it represents? Within circles, what is this symbol going to represent? So we're going to use a standard toilet paper roll, just the core, to help us understand with a few measurements a special ratio. And then the ratio, we're going to put it in fraction form, and that's going to become our factor. And we're going to discover, let's just make a note right here. Our fraction is going to simplify to the factor of 3 times 3.14. And this exists for all circles, no matter how big or how small. All right, so we're going to use the centimeter side of a ruler, and they're a little squished, but I'm going to use this measurement here. It looks like it's right around 4. Should be 4 centimeters. So the distance across the circle, so we measure all the way across the circle, and this one is going to be 4 centimeters. And this distance across the circle, we're going to call this the diameter. Okay, it's going to be how big or how small, how wide is that circle. Okay. And this is the diameter. Now, if we look at halfway, if we look at halfway across the circle, so from the center going over, from the center, it's only going to be 2. So all the way across is 4, but right in the middle. So this halfway point from the center to the outside of the circle, we're going to call this the radius. So we got the diameter and the radius. Okay, and the radius is equal to 2 centimeters. So let's just make a note of that right there. Now, if you want to label down below what we just did, so across this circle, all the way across is 4 centimeters, and then the halfway measurement, oh, wrong side, inches, here we go, and then the halfway measurement is going to be 2 centimeters. So the radius is 2 centimeters. All right, now the next thing we're going to measure is the distance around this. Well, this can be crushed down, so we can take the total distance around and just make it a linear measurement. And we're just going to measure how wide is it. So it's like 6.5. So on this side it's 6.5, and then just a little bit more. And so I'm just going to do 6.5 and a little bit more, and we'll see what that measurement's going to be a little bit later. And then the other side is going to be the same. So 6.5, that's going to give us, is that right? Let's see, I'm going to round that to 13, 6.5 to 6.5, that's going to give us 13 centimeters. So we got 6.5 plus 6.5. So, and we're going to call this the circumference. So that's going to be the circumference. That's going to be all the way around the circle. So we flatten the core, and we're going to measure the distance around the outside of the core. So the total distance around the core, we're just going to estimate it to be 13 centimeters. And this distance around a circle, we don't call it the perimeter, for a circle, we're going to call it the circumference. Okay, so we got the circumference, and these three things, diameter, radius, circumference, and then ultimately we're going to do area. So these are the most used measurements for a circle. And I'm actually, let's put a radius in red and then area in red. So those two things are going to be used, and then diameter and circumference will be in blue. So what can we do with this? So the circumference, if we divide the distance around by the distance across, and we set it up as a fraction, then it will give us this special factor that exists within all circles. So this is going to be 13. 13 was the circumference, and the diameter was 4. All right, so now we're going to do 13 divided by 4. So 4 goes into 1 no times. 4 goes into 13 3 times. So 3 times 4 is going to give us 12, and then we subtract, bring the 0 down. 4 goes into 10 2 times. 2 times 4. Let's see, 2 times 4 is going to be 8. And we bring the 0 down, and then 4 goes in there. So now an estimation here is going to be 3.25 for this factor. Now, more specifically, if we measured it exactly correct, we would have got 12.56. So 4 times 3 is 12. 3 times 4 is 12. There's no remainder. Then 4 goes into 5 one time. 1 times 4. So once we're done dividing, we're going to bring this decimal up. So this would be the most accurate measurement in factor that we're going to end up with. But the circumference was the distance around the circle, and the circumference was, we're going to use 12.56 centimeters. And when we divided 12.56 by the diameter, we got 3.14. And that 3.14 is going to be our Greek symbol. That's going to be our factor in which we use for pi. So once we've determined that factor of 3.14, this ratio of pi, which is 3.14, the ratio fraction factor, we can also use this to help us find the area of the circle. So the area of the circle, we need a length times a width in order to get area. But the measurements that we're going to use within a circle is going to be radius times radius times our circle factor, which is going to be 3.14. So it's noted right down below. So we did this already. So 1/2 the diameter is 4. 1/2 the diameter is 4. Half of that is going to give us a radius of 2. So now that we have the radius, r times pi will tell us how many square units it would take to cover this entire circle. So doing the first two things, radius times radius is going to be 4, and then pi is 3.14, and there's a little space here in the middle, so we can set that up. So we're going to multiply the radius times the radius, which would give us square units. Radius times radius, and then we multiply it by 3, which would give us the area going around the circle. Well, you multiply it by 3.14. So let's go ahead and do that. 4 times 4 is 16. 4 times 1 plus 1, we got 5, and then 4 times 3 is 12. After you're done multiplying, then we look at our decimal place value. We have 2, so we move it over in our answer. So ironically, for this, the core of the toilet paper roll, the diameter is 4 centimeters, the radius is 2, and the distance measurement, the circumference is 12.56, and then coincidentally the area is also 12.56, but this is square units because we multiplied centimeters times centimeters. We did not multiply centimeters here. We just multiplied it by a factor. So let's fill this in, last part. The area of this circle is going to be 12.56 centimeters squared, and the circumference is going to be 12.56 also, but it's only going to be centimeters because it's a linear measurement. Okay, well, thank you for joining me for the circumference and area of a circle math lesson, where we took a look at the special ratio of pi in circles, and that special ratio is going to be 3.14, and that is our pi symbol. So let's glue that into your journal. Use these formulas. We're going to leave them here. So we have circumference, whereas circumference times diameter. Here's the area formula, and then I covered it up. Circumference formula and area formula is what we're going to focus on this week.